Is the set of 1 closed under multiplication? What do you think? Yay or nay? Yes or no? Yeah, absolutely. And if the answer is no, we give a counterexample. All right, well, the answer was not no, so we could just say yes. And we don't have to do anything more than that. All right? If you're anything like me, you're like, all right, that's cool. But for the kid next to me, can you explain why that's a yes? I get it. I understand it fully. But the guy to my right has no idea. All right? So you just kind of dump it on somebody else. All right? What you're dealing with is the idea that you're taking the number 1 and multiplying it by itself. All right? Will you ever get anything other than the number 1? No. All right? Is the set of 0 and 1 closed under multiplication? Meaning, we say yes? All right, so meaning, will I get a number other than 0 or 1 if I multiply these two in any way? Well, let's try it. Yeah, the answer is no, so it is closed. So 0 times 0 is 0, check, that's part of the set. 1 times 1 is 1, check. 0 times 1, 0. No matter how you multiply these values, you're always going to get either a 0 or a 1, so this set is closed under multiplication. Zero, 2, and 4, closed under subtraction? No, give me the counterexample.
0 minus 2 is negative 2.
Exactamundo. And all you need is one counterexample. All right, one instance where the property fails, and then you can call it a day. All right, you don't have to show all possible cases because that could get out of hand pretty quickly. 2, 4, and 8 closed under division.
2 divided by 2 is 1.
2 divided by 2 is 1. Counterexample, so therefore not closed. Now, you may not have come up with 2 divided by 2. Maybe you said 2 divided by 4. Maybe you said 2 divided by 8. A lot of different possibilities. Bottom line is you just need one case. All right. Now, the ... in numbers 5 and 6 mean that the trend that you see there continues. So can we say 2, 4, 6, 8, which appears to be, at least most, 0 is considered an even number, the set of even numbers. If I add any two evens, will I get an even? Mm-hmm. Yeah? Yeah, so this is closed. This is going to give me a yes. Now, if it were subtraction, different story. Because it's not ... in the opposite direction. It's not like forever in the negatives. All right, so if I did 2 minus 4, I'd get a negative 2. So that would not be closed under subtraction. But for addition, it would be. All right. Now, what about the set of odds under multiplication? Multiply 2 odds. Will I always get an odd?
Yeah.
Seems that way. Anybody think of a counterexample? Now, there's a line of thinking there where you might sit there and say, well, I can't think of a counterexample, but maybe there is one and I'm just not noticing it. If that's the case, I mean, there's a chance. You're taking a chance that, maybe you're just not right. But odds are, if you've really considered the problem and you're really thinking, all right, let me try a bunch of different cases. I'll try a number multiplied by itself. I'll try consecutive values multiplied. I'll try values that are very far apart multiplied. Try a bunch of different instances, and odds are, if you can't come up with a counterexample, there probably isn't one. All right? I mean, there's exceptions to every rule, but you never know. The odds are in your favor. There's a chance, the tiniest of chances, that you miss something, but odds are you accounted for everything and you're fine. All right, so we're gonna say, yes, this is closed under multiplication. All right, and what we're able to do is generalize some things. All right, if you multiply a number by itself, there's no telling what the result can be. All right, because if you're dealing with evens and odds and stuff like that. But what we just learned is that it's a rule. If you multiply two odd numbers, you'll always get an odd number. If you add two even numbers, you're always going to get an even number. But then you could generalize it to other things like, I wonder what would happen if I multiplied any number by an even number. So if I take any whole number and multiply an even number, what kind of number am I going to get as a result? Odd, even, positive, negative, what are we looking at? Multiply any number by an even number, what kind of number are you going to get? You're going to get an even number. Okay? So you could kind of extend these generalizations to other types of values. Right? That's going to come in handy, unfortunately, late April, May, just far enough in the future for you to have forgotten all of this. All right. I'm kind of serious, but kind of not. I'm kind of joking because we'll have started Regents Review well before that. And so a lot of these topics we will have reviewed prior to that unit. So I think you'll have a fighting chance, more than a fighting chance. You should be very successful with that. But there are units of study in math. There's entire courses, it's called number theory, that really just relies on you being able to generalize different types of relationships based on the numbers that you see. All right. So all of that is really justifying what these rules say. All right. If you understood closure before looking at this section, don't look at this section. Okay? This is for the folks that are still a little iffy on my explanation. You're like, I'm not quite there. Doesn't make 100% sense. Then read through this. I think it'll help. But if you got it, if you understand, you feel like I got this idea of closure. Please stop talking. Then ignore this because it might actually undo some of the understanding that you have. All right, and so what we have here is a little bit of a practice section. That first problem is actually a solved problem, so you're